Hello, Adam. Hello, Alison. Please confirm if you hear.
Yeah, I can hear.
Oh, excellent. Excellent. Thank you. Hello, Nate. How are you? Whew. So you don't have specific program, just open your equipment, Matlab, and start working, and I will visit one by one. So that's a plan. Hello, Sibyl. How are you? Anyone needs to depart urgently, or your schedules are okay? Lola told that she needs to depart urgently, but maybe she has already departed. And maybe I'll start slightly different order.
I just realized I have a missing data point.
Okay.
So I'm just waiting for it to go.
Did you try eigenstates?
I wasn't able to figure it out because I was trying to replicate what you did yesterday.
Didn't work?
It worked at first, but I couldn't figure. But then it's not working. But now it's not working, and I can't figure out why.
Okay. So after this run, probably attract my attention, and we'll try to figure it out together.
Yeah, if you need to go, so other people.
Yes. Okay. Just a second. Lola, Joe is trying to do eigenstates, and if you did it, if you practiced and it did work in your case, you can briefly chat with him, and so that, and later I will join and we'll resolve his problem. Joe, please consult with Lola, because when she's ready, I think I interrupted in the middle of discussion, but she did two-dimensional eigenstates as well.
Did you figure out something with this?
I didn't have time. Did you?
No.
Okay, but let's. It is not needed for your report on Friday. It is needed for your presentation. So we'll have one more meeting in a week on Wednesday, and then I will certainly try my best. So, are there any other things?
No.
So, do you have draft of your manuscript, of your report?
Haven't quite finished it yet,
But do you have the file?
Yeah. What?
Do you have file with your manuscript, with your written report?
I do have like.
Okay, let's look together.
I mean, haven't like typed anything, but I do have
Figures?
Yeah, figures.
Yeah. Please show. I'm very curious.
I mean, I do have a lot, so I have to figure out which one is which. Okay, so I think I have something. No, not that.
So what I suggest, if you haven't started, then I have a suggestion. So open PowerPoint, not Word, but first PowerPoint, and insert all figures that you have there.
All right.
And then we'll look together and decide how to arrange them.
Yep.
Can you do it right now?
All right.
Okay. Did I share the most recent version from Samir? It is like version 37 last 2 days ago. If I didn't, I can resend. So there are. Okay, I'm resending. It will be just forwarding his email, just in case. Do you have draft of your work?
I haven't really started too much on the report, which
But let's.
I have.
If you have file titled report, maybe let's look on it just briefly. And
I have
makes
it on my home desktop. But I put all the data on this. I ran tests with Intel at different values.
that's great. But yeah. Is there anything written in the version on your home disk?
Not really.
Okay, then let's start right now. So writing is a big challenge, even if
Well, I feel like I have good ideas for the first 3 parts. It's more the discussion part that I need to still work out more.
Yep, but again, you are the boss of the project.
Yeah.
But my suggestion is that start putting things together and have them maybe as a scaffold to look through and have some feedback, because even if you have crystal clear thoughts, writing takes time, even in short manuscript. So if you have started something, is good. If you didn't, then probably start pasting all figures that you have completed into either Word or PowerPoint, and then if I'm nearby, we will look around and arrange them in logical order. If you're on your own, you'll do it yourself, but I would do it immediately, even if some data are not complete. Okay, and I'll stop by more.
So based on our discussion last
Uh-huh,
week, so I adjusted and did a linear kinetic energy instead of linear momentum. And then I adjusted it so that the temperature was in a reasonable amount instead of 11,000 Kelvin. And so the problem I see so originally we're supposed to plot the ln of the KT with 1/time, and because the only way to get temperatures in a reasonable value is to pick such small kinetic energies, and the change between them is so small that it doesn't change until every like 4.
I see.
But if I plot, that's with rate of reaction, but if I do yield of reaction, obviously these change every time, and so these get a better.
Okay. So what is your x-axis?
1/time.
1/temperature.
1/time.
1/temperature.
Temperature, yes. Yeah.
Okay, and the smaller temperature corresponds to bigger 1/T, right?
Yes.
So most realistic thing is here, the slope of the rightmost part. Okay. And
That is
did-
if we, that's with yield, not with the
Uh-huh.
rated reaction.
and the rate. Do you have examples of the rate as function of time? Not rate, but population as function of time. Oh, you will be next. I got you. Man.
I don't think so, because it's all versus temperature.
But so when running Matlab, you didn't record sample trajectories. I mean,
Oh, like,
yield as function of time. Like how?
no, I think I just recorded the yield, not the,
Not the trajectory.
so. Oh, this is gonna look funky. So,
Yeah, I think we have actually to look through once. It's quick.
so I've been recording just the rate, and then I just adjusted it so that it output the final yield.
Okay, and you're telling how the rate is computed? Is it like by feeding to exponential, as we discussed? Or it's
Yep, the rate is the,
okay, and you're telling that the rate doesn't change if you increase temperature, so it's like fixed.
it does change if you increase temperature, but if you, when we're,
You're telling that it is increases in steps by not instantaneously, but by if in some range of temperatures it doesn't change, and then it changes instantaneously.
right, because if the working in a reasonable temperature scale,
Mhm.
so between 158 and 317, it's one value, the rate is one, and then it changes at 400, but then doesn't change until 630 again.
Okay, so this is unusual, right?
Yeah,
And maybe answering this question would be a very interesting byproduct of your research.
okay.
So would you save, for example, the yield as function of time that you just showed? Can you bring back Matlab? The image, no, not the this one. So it's erase top two. Just will it work? Okay, we can do it. Okay, it will be just quicker to type them. Typically, there is a little arrow, but if it doesn't show, maybe it will be quicker to reset the range. So we go from 0 to 70, and then from maybe 0 to 0.1. So save this figure, record what were the parameters, like momentum, and then go to the next momentum, next temperature, and show this figure, and do not just display, copy paste into your Microsoft Word or PowerPoint, so that you can work. Today we are converting from doing research to describing it, which is also a challenge. So have at least 2 examples, and then compare, like if the rate is absolutely the same, it means the figures should be the same, but I doubt it. So please do it. idea what to do, right?
Yes.
Okay, yeah, thank you. You know how to focus on smaller,
Keep the axis.
yes. We'll be able to have a draft by Friday. Just collect figures that you generate and briefly describe them, a couple of pages. Oh, thank you, thank you.
I remember the last time I was trying to like change the axis because most of it were going into that's what I have for now. Because most of it were going.
Mhm.
So I'm trying to change this.
Okay. Uh-huh.
I didn't need to change it.
So we will figure out the technical aspect, but here is on organizational. Of course, you are just volunteering and doing audit, but in order to get maximal benefit from this activity, it would be very healthy if you do a written report and presentation. And if it is still a plan, there is very small amount of time, and instead of generating new data, one should just rush and use the remaining day just to align best figures that you can explain into Word file and explain what you see on them. So it is basically, if you want to stay in the same timeline as everyone, it's a top priority. Okay, so now I made a notice of your question, but did you? Oh, just a second. I have a clear mind and just need to express it in words. Did you try to save the figures that you generate not as Matlab objects, but as graphical into PowerPoint or Microsoft Word?
No, I did on my Matlab, but I could just snipe them out.
Yep. So I think today is time for it. Even if it is not perfect, just time flies out, and we will not have a chance to revisit many things. The semester will be over in like 10 days.
Like that doesn't have it well.
Yeah, we will fix it right now. I just given general direction. Another question: did you record the images, the figures of the emission spectra?
Before doing the manipulation.
Well, after, so as I understand your work myself, it's like two-stage process. First stage, you run this dynamics, and second, you run the code that generates emission spectra. Yes, I want such spectra after each run. You do not need to manipulate anything in this. So what this piece of code does, it post-processes the output of this code. So it takes that data from there and builds absorption spectra based on this calculation.
Right. So not to run this as I'm changing things in this, right?
Yes, as soon as you change something here and run, then after run this one, and it's very important to save the figure that it generates. Okay, so you've got, if like time is limited and you do many other things, like very, very minimalistic amount of data and format of output is like a big table, maybe 3 columns and let's say 5 or 55 rows, whatever you have time. First column, values of parameters. It could be more than one parameter, just explaining how what do you change, like x, e changed, blah, blah, blah. Second, whatever you get after running this code, or how the potential surfaces come together, where the wave packets are. And third one, result of this code, the spectrum, emission spectrum generated. And then by looking at such table, you see how parameters of the model change your emission spectrum, and it will be something of scientific value.
I don't remember what parameter it is again.
Mhm.
Then where do I get the X label, the label for the X and Y axis? I'm just gonna start all over again. So I'm just wondering where I can put the label so that I don't have a blank
Okay.
thing like this.
Okay. If, well, we can scroll through the code and find it, but if something is missed, one can just quickly type in commands. So if you work on this figure and well, first there is same as you just, I do not like it because all graphical things are slow. Yeah, maybe it's not the best idea. Can you please bring up the command window? Okay. No, she's at home. Do you need her for something?
Dr. Hirschberger told me to send my rotation reports from last semester, but I didn't write reports for her.
Mhm.
So I don't know what to write to him.
Rotation report for last semester. Okay. Did you wrote it? So just close this for 20 seconds. Let's discuss your case now.
And the presentation.
I understand, but I do not know all details of what is going on in the Dr. Cleveland's lab, but anyone who is in my group are writing written reports. Did you write like as a drafts for future papers? Did you do anything or?
No, I didn't write any draft. I only had presentations.
Okay, were they recorded? Yes, on Zoom.
I assume because like the Friday, I presented on the Friday group meetings.
Okay. So, and he needs it like today?
Yeah, because like the
That-
people who did for fall,
Mhm.
their report was submitted yesterday.
Okay, then just to have something on the record, just send slides. I think if it is already deadline, if there is no time to change anything, send slides and tell that the rotation advisor accepted it. If he will be not happy, then the quickest thing to go through is to take. I will help Svetlana to do it. Go into her Zoom account, open the day when you are recording, and it makes conversion of the words into text. And then it will be like 10 pages of text that you were speaking up. It will be with a lot of grammatical errors, not because of you, because of this robot does errors, but it still will be some text. Okay, but it is a plan B. I hope John Hershberger will accept
Well,
just
maybe find a copy of the behind it.
yes. Okay, so for this project, you've got general idea, table, and then after it is done, write text. What is done? Now access. You want labels, right?
Yeah.
Just type X. Whatever you. Maybe it's not maybe not angstrom. Maybe it's atomic units.
That's what I'm doing.
Okay. So also I noticed you were using let's look through everything. Number of points 400. Then I'm looking for the line that set ups X. Okay. Now let's look on the. I don't like the full screen. I'm too stupid to fight this. On several windows at the same time. So what? Yes, capital X. So X is defined here, right? Did you recently run the code?
No, I didn't run it recently. I have to run it now. I haven't run it now.
Oh, okay. So what's the name of this primary code? VP Marcus. Plus B underscore.
Oh, the answer.
Okay. So right now you did set that equilibrium position of both parabolas are equal, right? Which means there will be no stock shift. And then you probably are planning to slightly change. So if you want, after it is done, if you want to change access, it is typically done by command access. It's one can either put it into the code or just type in the command line, like access round rectangle and then first, last for numbers. So if you want to make it narrower, you do like 4.7, 5.2, and then from 0 to 0.1, and then it will focus.
Just access.
Axis, yes.
How do you
AX.
define the X? Oh, the X.
First
put the X
and last, first and last. It is what you were trying to figure out. And then you do not manipulate the actual variables, you just manipulate how it visually appears.
Mhm.
Make sense?
Yeah.
And then you do like first column some data, you copy paste from here. Second column, you probably manipulate this view and put it second column. And for the third, you run the code this with eigenstates, yes, and put spectrum there, and then repeat systematically. Make sense? Okay, yeah, thank you. Huh?
This one, like, it hasn't stopped running, right?
It was busy. So do not try to run anything else. Wait. So I briefly talked to everyone, right? Except Sybil. I'll probably talk to Adam because he may feel lonely on the line. Adam, how are you?
I am good.
Would you? So let me make you co-host.
Yeah, sure. One sec. Let me get my headphones. Hello?
Yes, I'm here.
Oh, okay. Just making sure they work.
If you really want to see me, I can magnify the camera.
Okay. I have.
Hello, Adam.
Hello.
Okay.
I have kind of a shell of
Excellent. I'm so happy. Although it is not very many things, but you have
yeah.
pattern.
Yeah, it at least should help me break the parts down.
Mhm. And the pattern, you do not have conclusions.
Oh yes, it's good. Good call. Oh.
Like IV, not for intravene, but for Roman 4, if you're already using conclusions. Good. you can use formatting later. It's a reminder.
Yeah.
You won finally. Good. So, okay, that's beautiful. What is your PowerPoint?
Oh, I don't have a like a. Here's the PowerPoint I have all the data in.
Yes. So here is your PowerPoint with all data. So you have 24 slides of figures, right?
Yes.
Now you are under serious challenge how to select. You cannot do scientific paper with 24 figures.
Yeah. I don't expect to use all of them. I expect to mainly use the updated one of this. Maybe the yield graphs, and maybe one or two of these to kind of explain energy offset and
Perfect.
how it pertains to
this is a great plan that I am very happy to support. So let's go back to your Microsoft Word
Yes.
and go into your section 3.
Okay.
Section 3.
Oh, oops.
And I will just request control if, but it's probably better if you type, but I'm just suggesting. So figure 1. So what are you going to put there?
Here, I think I'm going to put the expectation curve.
Expectation.
No, maybe not the expectation. Maybe I should put the actual curve. So the updated version of this with more points between 0 and 0.01.
You are the boss. You do whatever you like, but let me give suggestion. So which you are free to reject or accept whatever. So figure last, whatever, I don't know, 10 or 5, figure number last. And here you give the main result. Main result, Marcus rate as function of, I apologize for mistyping, I'm just in a rush.
Okay.
Function of free energy offset, right?
Yes.
Offset. And this will be your last figure. Maybe if you find it reasonable, you can make it first, but maybe not. The first could be just explanation of what is Marcus theory, just general parameterization, like what is reorganization energy.
Yeah.
Notations. So maybe better notations and general view of parabolas. Maybe
could I
go ahead.
Could I put that in introductions? Would that be a better place for it?
Absolutely, absolutely. Yes, yes. Control X. Control V.
Okay.
Okay. Then here I really do have intellectual challenge for myself. So suppose we follow your idea and call this will be figure number 2 with main result, right?
Yeah.
And then we can arrange figure 3, typical examples of parabolas arrangement for delta E smaller than 0, equal 0, bigger than 0, or like limiting cases.
Yes.
Okay. Then figure 4, typical examples of I think if you have eigenstates figures, eigenstates would fit here better. But again, feel free to rearrange eigenstates for the same parameters as in figure 3. Figure 5. So it will be like 3 panels, right? Here, A, B, C, and same and then keep the same pattern.
Yeah.
Typical examples of eigenstates. Then next, dynamics may be questionable. Examples of dynamics in form of snake color stripes, right?
Hmm.
So
Yeah.
you record them and you can show them also ABC.
Okay.
Okay, then figure six, second main result. Typical examples of what? Of the population of acceptor as function of time.
Yes.
Acceptor as function of time. And I think that's it.
Okay.
Your idea is to have numerations like 2, 3, 4, 5, 6. I would probably call this one 6, this one 2 prime,
and so on.
Yes, it will be your decision. I don't care. You are the author, but 4 will be 3, 5 will be 4 prime, and 6 will be 5 prime. Then
Okay.
you tell a story. I did this and that, and here look at my main result.
Okay. Yeah. So you think giving the background should be helping me lead up to the explanation of my results?
Mm-hmm.
Okay. Yes. Okay.
My spelling is terrible.
It's okay. So it's hard to do it over the remote.
Okay, and maybe let's do again. I'm offering something, but it will be your decisions. Discussion separately from results, and you do not need to write twice as much. You just split and categorize things.
Yeah.
Main question is why ideal Marcus curve deviates from computed results, right?
Yes.
What is the reason for dramatic fluctuations? So
Yes.
it is kind of, I would call it cons. And the pros are that in the limiting cases, both approaches provide vanishing rate.
Yeah.
In the limiting cases, delta E much bigger than 0 and delta E much smaller than 0. Both approaches provide vanishing rate. Do you agree?
Yes. Yes.
In the small DE range, small DE range, both approaches give maximal rates. And overall maximum is not symmetric. It is shifted towards positive DE bigger than 0. Is it what you found?
Hold on.
Let's look on your PowerPoint with your main. So see, the peak is not at 0, but it is for positive delta E, right?
Yes. Yeah.
Computed results are also have maximal values not in the center, but they're non-symmetric. It's shifted towards positive, right?
Mm-hmm.
So in these three aspects, your computation agrees with Marcus theory. And disagreement is that you right now you need to explain why these fluctuations are coming up.
Yes. Yeah.
Okay. I think you are in a very good situation. You just let me make another suggestion. For figures to look beautiful with these panels A, B, C, D, I would create separate PowerPoint slide, which I would call figure 3, and then place their all panels and make sure they look nicely, like arrange them, and then put into the final version only the graphical form. Because if you start copy pasting separate images for each panel, the formatting may affect them adversely.
Okay. Yeah. Yeah. I plan to do that either in PowerPoint or in Excel. But PowerPoint seems.
PowerPoint. Okay. I'm sorry for talking too much. I probably should be more attentive to your question. So, did you wanted to ask something specific?
Yes. So is it is it appropriate that there's like no abstract? Should there be an abstract or no?
If you want to submit it as a paper to a journal, yes, it should be an abstract. For the class, it will be a very broad variety of styles.
Okay.
Okay, yeah. What is the other question?
Yeah, but is this going to be very short section? Like, do I even do I need to put a lot?
I'm very behind my own plans. I want to share with you guys the written reports from previous years, and I did targeted transmission to like a couple of authors, but I want to send all of them. I do not mind if you get inspiration and even little copy paste from there. So
okay.
This methods is not maybe what you developed, but it should be a little bit more than 0 details, right?
Yes. Yeah.
Okay. So in some sense, you're helping me or next instructor in this course to teach it next year, so that whoever will read your work will be able to hopefully repeat your results.
Yeah, sure. We can do that.
Okay.
I don't think I had any other questions actually.
Yep. You can stay online and we can chat in the second round. I'll make a circle with everyone and then ask if you develop more questions. But right now you can stop sharing and just focus on developing this report.
Okay, perfect. Thank you.
Thank you. Are they dogs or wolves?
Oh, it's from a movie. It's a dog
Oh, okay,
and then whatever that is, a hamster.
okay.
So I played around with changing my momentum or whatever, and I noticed that my probability still came out to be the same. Basically, the graph, when I plotted the graph probability versus time,
Mhm.
it was identical, even despite the fact that I changed my momentum from like say now it's 0.5, but I changed it to 0.5, I made it to 18, I changed it to 0.9, but still the graph didn't change.
Mhm.
So that's
Please repeat, in which range did you change the momentum?
so I changed it to 0.5, 0.9, and 18. 18 was the maximum just to see if it's gonna actually change.
Okay. How long does it take for a single run?
Well, now because I've changed some stuff, it should take like 3 minutes.
Okay, so you can do like several runs. It is not a big deal.
Yeah.
So it's -20 right now.
Yes, -20. And I also changed the peanut to like different, changed the peanut to like 1, -1 to see if that will help my change.
Okay.
But it didn't change anything. So I played around with the peanuts.
So first we want to test that by changing initial parameter you can
Change, yeah.
change output. In
Exactly,
general,
exactly.
it's yet far from scientific analysis. Just make sure that there is no error. It's programmed well. So what if we, instead of momentum, what if we change
Position.
position? Yes.
Yeah, because that's all. Okay.
So right now,
It's 4.4, so we can change it.
what if we put y equals 4 or 3.9 or 4.9?
4.9.
And yeah, save and see what happens.
Equals one.
Okay.
Thank you. Let's save this and close this one. This one.
It's real quick.
Yeah. This is,
It's
the first time it doesn't run as always. So the second time run.
so I think we miss. Well, I should take responsibility for this. The
Did I do
labels, the x's are mislabeled. I think what we call y is x. What
yeah,
is it?
but yeah,
Yep.
I know. I'll have
Yep.
to think.
But if hypothesis was correct, right now,
It shouldn't be here though.
right now the product will start from being close to 1 right away.
Mm-hmm. Oh no, we changed position. Yes, it should be here.
So if you integrate
Yeah.
this area,
Yeah. So basically, yeah, this should be the ON and this should be
Mhm.
INN.
it's interesting that yellow and blue move so quickly, and the black almost shows almost no change.
But when I was monitoring for a longer time period, like it takes time for the plot to change. Like eventually it starts shaping like the rest of the currently tau equals 1 or no. Yeah, tau equals 1. Next time maybe I'll make it a little bit quicker.
Hmm?
So maybe next time I'll make it a little bit quicker.
If you make it too quick, then it will start making ugly.
Yeah.
Does it? I know that in one of the versions it was typing
Not
the time, yeah, inside. Did you remove it or it is? Oh, by
it should be still on. It should be on. Okay.
just to see how far it progresses. It should be inside the loop. Near maybe line 400. Is it different?
I'll need to put the. I need to figure. It's different.
Okay.
Because initially it was
Mhm.
like on my phone.
Okay. But
Yeah, because initially it looked like it,
mhm.
and it stayed the same for the amount, any amount of
Okay.
momentum I took.
So what I'm not, how to say, not happy and a little surprised that this is still a small number.
So, yeah,
I would expect it to be close to 1.
yeah, it was, yeah, both cases tend to be
Mhm.
-6.
So let's figure it out, and then if you do it, then everything will be set. Can I type something? Yeah, just in case if you. Hmm.
Did you like the mouse or anything?
I'll try to. Okay. And we were playing in here. Make it a little smaller. Okay. So PR2D is so small, and definition of PR2D is just to. So the sum. No, probe. Probe.
3. That's right.
Okay, 1. Now, if we this one, it should be the same. Now, if you do from n points divided by 2 plus 1 to number of PTS. Okay. Now but if you do from 1 here, what? It cannot be so. From 1 to number of points. Okay. Very strange. It looks like X counts from opposite. What if we do by 4? At least we can control it.
Yeah, so it shouldn't.
Okay, let's play a little bit more. So here is one.
Yeah.
If we do everything here and here from
Yeah.
1 to number and PTS by 2,
One.
still 1. No, it can't be this way. It should be half. And PTS by 2. I think we need to redo this procedure by hand with a little more responsible programming. And if you fail, we'll ask help of Wyatt using his talent. So probe 3 XY, okay. I have an X, Y, Z. Maybe it's out of plane. We need to put it a little to the top. Maybe before we start doing right here. So do we use I and J?
Yes. I equals 45.
Okay. Do we use I?
No.
Okay, maybe I1. I. J.
No.
Okay. So for and also, how do we know? Let's say border X equals, so number of points divided by 2, but let's do it in if number of points 35.
Yeah.
Not
45.
55.
45.
Let's do it halfway, like 28. Border Y also 28.
Okay.
So for 1, 2,
Okay.
X.
Border Y.
So we can split the space on 4 quadrants. Probe 3. One can do the following more elegant, but I'll do just very silly thing. repeat it 3 times. Control V from border X plus 1 to a number of points, and then it will be 2, 1, 2, 1. It's very non-elegant programming. I do not want my teachers to see me doing it. So now we can go from one to border here, and from border plus 1 to endpoints to NPTs. And then it will be 1, 2. And then the last one. Yeah, thank you. Okay, and let's debug just this set of lines. No errors, no. Cool. What? Oh, no, yes. Of course. I just want to make it very basic, explicit way so that to avoid any possible errors. Yes. Okay. Let's try once again. No, of course, 2, 1. Okay, Q, whatever. Okay. This test is fine. So we just need to find the right border. So I think Q11, it looks like this area.
Yeah.
So Q11, how we defined it, it is our product, right? So if it is Q11, then it is in the right edge. And then we probably need to accumulate all these 4 and then later to try plotting them. So before the loop will set. Not, yes. Okay. So we can probably bring the initial values to whatever it was before, rerun, and if the results will be still doubtful, we can play with border parameter, put it smaller or bigger, or is so which one? Okay. 2. Let's do it 3.99 just to be in the border, and then now please arrange either keep or erase panels and maybe it's correct. It's why we can right now it's not change things, but maybe it's Y iron to nitrogen and this X because the arrangement of the potential energy surface looks reasonable. I think it gave error because of touching the screen. So it thought that we changed the aspect ratio of the figure. And also maybe I did wrongly change the here. So it tried to put something away from the, but we can put the, I think it was still accumulate. Okay. Okay, it looks like it's already in the product. and down.
H222. So I'm sorry. Okay. H222.
So I do want to remember or learn how to draw lines. Like if we do hold on, put okay, X of border X, Y of border Y, insert 1 by star, red star. I do not see it.
There's an error using plot 3. I think you should just put plot.
Okay, we can. Okay, I'm learning something. Everything is much better. Just need time. So 7 and 6. Everything. You have much more data away from here. So let's do this one. X of NPTS 10. Y of NPTS. So we do not need to go so far, right? So we need we do not need 10. We need only like from 2 to 6. It's like about 4. Here also maybe 5. We need to set dx smaller. Yeah, go ahead. Okay, so let's do it slowly. Do not change what we think. So right now maximum is 10. We need maximum about 7. So we need to make it approximately 1.5 times smaller. So if you do, it would be better. Maybe even a little smaller. Yeah. So it's yeah. Please arrange running like close, open, run. It's still going to 8, but it's better. Next time we'll use small number. See, now they came back. So it's dx, and no, we will not see it. But next, when we, is it running or it did stop?
It stopped.
Okay. Oh, because we were pulling figures. It is very nervous when it tries to capture the image. So the previous one, it was about eight, and we need 7. So we need by maybe 10% less. So 2.1. Okay, save once again. Hmm? Well, it will pop up new window if maybe I shouldn't type clear because it reassign variables. So maybe running over is a little quicker. Okay, it's running.
It's gonna go to Optical 400. Yeah.
So after all errors are fixed, with your project we are very late compared to schedule. So it's time to put writing, and it's already in danger to complete it within like 24 hours. So I don't know if you heard what I was telling to others. So when you do productive runs, try to copy paste images into PowerPoint. Even if you do not plan to use them, it's better to have safe collection because running takes time. And then design how you arrange your paper, and best way is to start with figures. So figures, if you want to see, maybe again, it's you're the boss of this project, but one of the options you can just select a single run and make a figure of like 5 to 10 screenshots of one run. Tell like here how things are going forward. And then another figure can be several examples of how this population will change over time after we fix. So it looks like phase goes this way. So because potential is over here, maybe it will go opposite, like back correction instead of forward in this little run. So plan on logical arrangement of materials is maybe even of higher priority than completeness of results, because
Yeah, I have some already have some materials.
Mhm.
Yeah, that I have put in a file. I
Okay.
just need to add
Yep.
an update.
Yep. So final draft is by Monday, but so after getting feedback from the class on Friday, you have a weekend to add more data. But for writing, it's better to have things done right now. And most, just I'm placing myself on your place. Most challenging thing is how to arrange figures, because when they are arranged logically, explaining them, it's like high school composition. It's a little easier, but it's truly creative process of arranging them.
should I still be putting there or not, or I don't need to? if I
Oh,
make sure
let's wait.
it's done?
500 is done. Yeah, let's get a confirmation that it works well, and then we'll. Okay, let's just do it here. 6. It's still too much.
No.
Oh no. And then if you do by of border, it should be correct.
Mhm.
5, 4, and 6. 5 and 4. 5 and 4. Okay, it will be some. Okay, now let's do. Those are eigenstates, right?
Eigenstates, yeah.
Yeah, it's also another figure. But what did I want to put? A, Q, and 1. That's perfect.
If you want to. Okay. Okay, Q2, 2. Okay. Okay, Q2, 1.
Okay. So maybe, well, you probably will be much, how to say, brighter.
Fine. Yeah.
Do we have a variable for time?
No,
We should. There should be a variable for time.
you have to.
Maybe. Let's try maybe uppercase.
Yeah.
Okay, and comma AQ and 2.
AQ 2 or 2. 1. AQ 2. So number.
Because the which one was the biggest one?
The AQ.
1. Yeah, if you remove
Yes.
okay, and let's do one more test run, starting with packet where it was originally, and then even with one run it could be good, but maybe at least 2 for comparison, making this work. So and for the next run, collect figure like this in your PowerPoint. So I need to talk to others.
Yes,
Like that. Okay.
thank you.
Yes. I'll just pick a chair.
So looking at, so these two are they have the same rate and they're on like both ends, but their yields are quite different. And they obviously their yields are different. The one with the higher temperature is a higher yield, but it's telling me that their rates are both the same. So is that an issue?
Let's can you please bring back the figure? What if you do rate estimation by hand, which is always less precise but more reliable? So just take a ruler and connect 0 and arbitrary point along this trajectory, which like assuming that it is linear, and make dy divided by dt,
Okay.
and check if you get the same or slightly different, and use this as a rate.
Okay.
And
Just pick like the same at the same time on. each
yes, yes.
Okay.
And then maybe then you identify that method to compute rates is malignant, and this very rough but well-controlled method is more reliable.
Okay. And then for the figure, is this kind of what you want?
It is perfect, but what I am surprised is that
So I added just numbers to offset them.
okay, let's remove this so that they will be back in there. Don't do things right now. You can do it later. So, what is the meaning of this operation? The potential and offset of eigenstates use the same scale. So it is a little strange that it will be. So you're telling that this image will be below -0.4?
It'll be between. It's like -0.3.
Okay, then it is perfect. Then let's do it. In order, just for visual effect, to avoid this overlap, we can do a little trick
So
and just divide something blinked here.
oh yeah, this one is if I don't offset them at all.
Okay.
Just plot it all the same.
Okay. So they are offset by energy of the first state, right?
So EEE is added.
For consistently for several states.
Yes.
But it is EEE is computed for the state number one, or you recompute it for each state.
Yes.
Yes,
Or,
which of them?
so EEE is
Computed once, and
No,
you
so-
used or computed for each of them separately.
so I do adjust the psi I for state number 2, 3,
Okay,
or whichever one, and then I will plot it with the adjusted value, with the adjusted,
but EEE is do you adjust EEE? I do not see.
like
it.
multiply times 2.
But do you adjust EEE?
It should adjust based on what psi I is.
But I do not see it here. Like, do you copy paste this line into here?
Oh, that's what, okay. And that's what I'll offset it.
Right.
Okay. That's what I was doing.
Okay.
I wasn't updating it every time.
Okay. And the making an offset of each state based on its eigenenergy, it's
More accurate.
it doesn't have to do with science, but it is a common way how people represent results. And if side like a guest, a visitor to presentations will come and see, it will be evidently clear what it is done. And if you show this one, it will a picky reader or viewer will immediately start giving you a hard time asking to explain what it is.
Okay. For figures on my document, obviously include the proper figure for this one with the kink and then without. And then should I include any graphs like these that kind of establish the relationship? I'm assuming I'll talk about the relationship between momentum and kinetic energy and temperature related to yields and rate of reaction. So should I include or I guess which one should I include? Should I include the ones with rate of reaction or just yield of reaction?
Rate of reaction is standard. Yield of
Okay.
reaction is a little novel,
Okay.
which can be brilliant or it can be not as useful.
Okay.
And I'm not telling that something is wrong here, but let's assume just very minimalistic amount of data based on our conversation and your calculations right now. If you do by hand assessment of the rate,
Mhm.
just one linear slope,
And
do
then
it,
we plot them.
report, and maybe if you have energy and time, report completely, but if you are limited in resources, just do two highest one over T, or which means two lowest temperatures.
Mhm.
And based on this, on the 2 points that you will get, extract the slope.
The
Yeah,
linear.
Yeah, extract the slope with and without king. And give these two numbers.
Okay.
So this will be something that has scientific value or something that mimics scientific value. So it's how the activation energy depends on the geometry of your molecular model.
So with the technique we talked about at the start, so picking a point and getting the rate.
You see that it will be different if you change momentum, right?
Yes.
Okay.
Yes, slightly. And then plotting the ln of the rate or versus you said-
1 over T.
Oh, temperature.
Mhm.
Okay. And so the rate, okay, like if we take just these two, for example, these two according to this have the same rate.
And here,
But if we do the rate, just say at 60 or something, obviously this is going to be a different rate.
it will be,
This one's much higher than this one.
yeah, 0.06 divided by 60. So it will be 1 to 10 minus 3.
But so that'll be much different than
And here will be
0.04 over 60.
1.5 times smaller.
Yeah,
Okay.
but so where would the problem lie in the code giving me the same?
Let's figure it out after getting some constructive result. I'm also very curious, but let's save the case and do something maybe less precise but more reliable, and then investigate. And I do not need to tell to everyone about this, how activation energy extracted from here. Should I, or you're fine?
I think I'm fine.
Okay. Yeah, thank you.
I'm still wondering how to find the eigenenergies.
Okay, yeah, let me focus on it right now. I just make sure that there are no quick. It will be doable. Okay. Everything under control?
I have quite a few questions, so you can maybe help Joe first.
Okay.
How late are you gonna end up staying?
I will get a call from home at 8 telling that I'm overtime, but I plan to be here at least one hour more.
Okay, I can wait.
And if things are getting distracted, you can just type your questions in the email, and I prefer answering personally, but as a backup plan.
I got them all written down, so.
Oh, okay. Yes. Oh, everything under control? You go. Okay. Yeah. Thank you. Okay. Yeah.
Pretty much have this number in here to represent the number ensemble value in the Matlab prod. And what I noticed is that the grid at this, if this number is increased, then this little bump here actually gets smaller.
Okay, that's
Yeah.
perfect.
Because if you compare here,
Uh-huh.
and then vice versa, I also did one when the value is 3, and here is a little bit higher than when the number was 4.
Mhm. So you may measure the size of this peak as
Yep.
function of number of ensemble and put it in a table.
Yep.
Okay. But we have not too much time, so plan how you are going to arrange these figures into written report, and maybe make multi-panel figures, and just so that you cannot do more than like 6 figures. Less is even better. So you need to neglect something or combine them into multi-panel, and it's most hard and creative part of the work right now.
So I figured out, so I got the graph for the eigenstates.
Uh-huh, that's
But
great.
I'm
Okay.
not sure how to, what or where to go from there.
Okay. So no one is requesting, of course. And you're saving these things into whatever PowerPoint or
Yeah.
Microsoft.
I just want to get everything together first before I throw it
Mhm,
on the
mhm.
PowerPoint.
Okay. So Matlab, which you did run the code and then you
Yeah,
found eigenvalues.
yes,
Which variable contains eigenvalues? Is it like UUVV?
yes, or the UUDD, but I think I commented it out, so I might need a. Yeah, I did, hold on.
Okay, yeah, please bring me to the place where you define UU and DD.
There we go.
Okay, yeah. So what I suggest we do make C a new code.
Okay,
And we call it states eigen 2D version 1. So variable D contains eigen energies, right?
yes,
And UU eigen states. States. Now, let's explore. Let's explore state number and state. Do you have this variable or not yet? And state. No. Okay. So for the beginning, and state equals 1. So we parse the state number and state.
okay,
It could be my comments, but I suggest to use new one. Parse the eigen state number and state out of the list. So So now the big C is only one eigenstate. This operation will convert column into matrix.
Okay.
Because so we have two indices, X and Y. Here they converted into one superindex, and here we make inverse transformation. This line creates probability distribution, which is a little softer. Without now we need just plot it.
Okay.
So instead of plotting ourselves, we can look how it was already plotted here. So it is momentum space. And here, later on, there will be probe 3 XY. Okay. I just harvest a couple of commands so that we do not redo it over. X and Y good. What else? And here are some ways to make it more beautiful, which we may or may not use. C. And Control. Needs to type hold on. What else? If you're looking forward to make beautiful labels, we can add text. From V. And here N equals and state X, Y, Z. Okay, now let's save. Open new figure. I'm just going to minimize it a little and run this new code, which we called states eigen.
So this gives us the eigenenergies.
I see what is going on. I just need time to
Oh, okay.
convert thoughts into words. I'm going to put %, but if you will be running like stop and rerun, this % needs to be removed. I just want to speed it up by a few seconds. Okay, hold off. No, it's still here. Let's Figure. So let's see what we are plotting. Oh, yes, here. Let's comma y. Okay. She's real, contour, contour F. Okay. Save. Finger. Okay. Okay. Phew. Much better. So now you can tell yourself what it is.
So the peak is so the peak at that eigenstate is the eigenenergy, is the corresponding eigenenergy, right? Just to
So
confirm.
for eigenenergy number 1, it is the two-dimensional wave function.
Oh, okay.
So eigenstate. We can also put energy here nearby. Let's do it because visitors and readers of your work may not have enough time to follow all details. Let's do another. Control C. Control V. So this. Maybe 0.3. Wait, no, 8 was good here, but we can here offset it, put here, and tell it energy equals. And here we do, so the variable dd contains energies, right?
Right.
So dd bracket and state, comma, and state, because dd is a matrix, right? We need to scroll over the save. Okay. -62 in which units?
Electron volts, right?
Okay. Okay, it's a little too, well, right now there is no time to change. In either electron volts or atomic units, it's a very small number, but now we are not going to change anything. Okay. So tell me what it is on your opinion, just.
So basically, at the first eigenstate, it has a energy of -62 point.
And it is distributed in space around the center of the atom.
Yes.
So it's like S.
Yeah.
1s
Yeah. The 1s.
orbital.
Yes.
Okay. No.
And then if I wanted to represent this for the rest of my nodes, how would I go about doing that? Like what part of the code would I have to change to?
Just change the number here
And
to 2, 5, 3, whatever you need.
okay. And
I just want to.
does it have to match the number of nodes that I use for each run, or like, so for example, if I did like, since I ran like 1.1, 1.5, like, do I need to change the end state to 1.5 or 1.1?
What is 1.5?
The nodes on the rotational.
No.
Okay.
If you are not changing potential, if you are not changing magnetic field, then this calculations once and forever. But I suggest you right now do screenshot of this image and put it in your PowerPoint or Word right now as we speak. Please do. Okay, now let's return to Matlab. Oh, you're adding them to, okay. So if you change this 1 to 2, no, 2,
Did I- Oh my,
2, save.
can
And
you close this out?
you can write over, just rerun, arrow up, arrow up. Does it look differently?
Kind of jumbled. So they're going to,
So there should be an option to rotate it. Oh, I think
yeah, it overlaps.
okay, then let's maybe close and type figure, arrow up. And now arrow up for the code. What do you see and how do you interpret it?
So basically, at the second eigenstate, there's essentially two nodes in the two the 2D space surrounding the atom, and it has at state 2, it has an eigenenergy of -25.
So it's bigger than ground state. How does it compare with expected p shape of p orbitals?
Looking at it,
Maybe we can tweak the colors a little bit, but would you agree similar to p orbitals?
yeah, because the
Aaron.
p orbital is like more of a dumbbell shape, right?
Yes. So it is dumbbell shape, right?
Yes.
We just
I'm not sure to show that though.
so if we what if we temporarily remove this one?
Yeah, there it is.
It is yeah, it is a little less beautiful than one may want. Let's do a little. There is a if you do this two things, it may improve visual presentation. Better?
Yeah.
Okay, so let's insert it into your code and maybe redo for the first state that they will be all consistent.
Okay.
Figure state number 1. Save. If you what else? For visual appearance, maybe we may want to move this one to the left, right?
Okay.
So X so closer to the beginning of the save. Close figure. Better?
Yeah.
Okay, so maybe save it as well and then continue the pattern. Okay, now it's
Do the same
changed
for-
to 2.
space.
Yep. Save and run. And if you're sure, yeah, if you select the way when it is X here, Y there, one can make it by adding one more command. Let me show, just so that in a production line you progress forward really quick. So VU2, so it's automatically orient this in.
Oh, okay.
So if you like it, we can put it. So it will do it automatically.
Perfect. You can save this as well.
Yes, yes. And we will need, I don't know, a dozen of them.
Because in the animation that I made for the rotation, I did I think so like 10 runs.
Mhm.
I think it was like up to like 5.5
Mhm.
nodes.
To get to this number, we will need maybe more than a dozen. But let's go through the progression and see how it goes. Mhm. So is it similar or different from previous one?
It's the exact same,
No,
or not the exact same. It's same energy, but it's oriented differently.
right. So it's like PX, PY, right?
Oh, okay. So I see what I'm doing now. So for each state, it has a different orientation in space.
Right.
Okay, that makes more sense. So then at each for the I'm trying to say, for the number of nodes that I changed in the other code, I'm making some connection. I just don't know how to word it.
So let me try my version, and then you develop yours. So and you don't need to follow mine. I'll just try. So you are trying to find eigenstates of this two-dimensional hydrogen atom in two ways. First, by educated guessing a rotating wave packet, circular wave packet, with a magnetic quantum number as a parameter. And you are just continuously changing this parameter and watching the criterion. If the state doesn't change in time, it is eigenstate. If it wildly jumping, then it's definitely not an eigenstate. So it's one side. Another side, you just formulate Hamiltonian, diagonalize it, find eigenstates, and just plot them. And then you're trying to make connections. So those runs which were mostly beautiful in your first run, I expected to coincide with several figures from your eigenstate analysis.
So I'm lost right now. So because these are the figures I have. So I took screenshots of
Yes.
after I finished running.
So let's collect data and then try to analyze.
Sure.
So it's
That's what I make sure I was looking at, right?
copy paste and keep saving images for at least 12.
For 12 of them?
12, and maybe I'll try to talk to others and I'll stop by and open them. Maybe we will need more.
Okay.
If you got up to 5, maybe we will need like 18, but keep collecting it, you will enjoy.
Okay.
And just showing them to the public or making a figure that lists several of those and explaining by words how do you interpret it will be very interesting and adequate for the project. So I just listen to you and see that you are making a very solid intellectual effort, and I make an impression that you're enjoying it. So try collecting, and when you see more of them, you will just have more material to describe.
Okay.
Okay.
Thank you.
Thank you.
How does this look? Pretty much have the three things put together.
Oh, you added together the results with
Yeah.
different size of ensemble.
Yep.
Yes, it's really great, and then you can explain the like solid dash and long dash correspond to.
Yeah.
Yes, I
Yep.
excellent.
Yep.
Excellent.
Thank you for the suggestion.
So here's the data I got. I'm not quite sure if I was doing what you had suggested. The biggest thing is, so I changed N to L, and I wanted to just change when the pulse is emitted, but it changes the length of the experiment.
Yes, yes,
Is that all right?
yes.
Okay, that's.
Because it is quite natural. It mimics something that one can do in experimental lab with very cheap setup, but it gives big. So you just change the shoulder of interferometer and redo and measure femtosecond response. So we do not have such equipment at NDSU because it's like setup will be like $500,000 for lasers. This leg with mirrors is cheap, but the femtosecond lasers are a little more expensive.
So
Oh, what is going on? So you have pulse number 1 at time 0, pulse number 2 at let's call it delta t, and then your simulation goes up to 2 delta t. And if you increase delta t, it automatically ramps overall duration. Right?
yeah, I was wondering if that's good. Okay.
But if we are looking for a time, we can select a time range before the second pulse, so that maybe look on a time scale, same time scale as in your shortest tau, to be comparable.
How do I?
Oh, you can just trim take the figure and just focus on the area which you need. You can modify it in map.
This figure.
Yes. So one can modify it in Matlab by the command axis, or one can just I'll do something which will break it, but you can fix it later. So one can output. And then crop, yeah, crop for smaller range. And in Matlab, one can set axis 0.5. I'll just write it down. So here is 0.5, here is like 7. Here you want it from 0 to, let's say, 50 femtoseconds, right? Consistent in all of them. So you write axis minimal x, maximal x, minimal y, maximal y.
Okay, where do I insert the axis?
You can do like if you run, then stop and collect figures. You can just type it in a command line after program has stopped. So you bring up the image you want to modify, type this in the command line, and then it will crop it, and then all images will look consistently. So can I erase everything except this little line?
Yep.
Okay. So if you do a very long duration between pulses, then so it's pulse number 1, then there is a time delay between first and second, and it progresses far enough, and then with second pulse you bring it up, but the distance it travels will be big, because here it's like gradient and constant acceleration. If we use shorter time, then second pulse will bring it back. And if you look for, maybe even if you set RAB equals 3, if you explore a little time after the pulse is done, here it has got momentum in positive to break the chemical bond, but the gradient here goes back. And if you look on this situation, your stripe will look for this position and time, right? Bluish white stripe on a blue. So first it will ramp to go away, and then it will start stopping, and maybe here it will return back. So it's a reconstruction of a bond. So by manipulating duration between laser pulses, you can control to break chemical bond or reconstruct it back.
Is that only if it's more than 2? 3 pulses per unit? I didn't get anything like that when I also.
How long the code is running?
It's not long.
Okay, let's rerun it, or maybe save so that we do not damage anything. So let's put RAB 3, and let's put tau a little smaller, whatever was your smallest. Okay.
It's not too far though.
Yeah, that's okay. Let's run and see what happens.
Might take a little longer. I was doing it on my desktop. So.
So now it accelerates, splits between green and blue. And now it goes down, and it still goes like to the right, but not as vivid as it would. So it stops, and if we wait for some time, it may even go down.
Why does it go back down to the ground state? That's what that's.
And now we go the third pulse that will probably continue going forward. You need to, well, I'll explain everything as I can, but you may benefit of briefly talking to Joshua, and he may also benefit from talking to you. Do you hear? So Nate and Joshua, if you just cooperate in understanding concept of Rabi cycles, which you use naturally, even if you do not formulate it this way, you'll get mutual benefit. So here you have like several states, right? And several states is too much for pen and paper theory. But if one focuses only on two states, which is actually the situation for Joshua, like two system, there is a so suppose we have two states and we irradiated by electromagnetic radiation. So electromagnetic radiation is arranged to be like nothing, then pulse, then goes again. So when radiation radiates, it continuously takes population, which can be like one on the ground state, and it promotes it up. But since it is probabilistic, it if you speak on the language of probability and wave function, it doesn't jump instantaneously. The probability of excited state as function of time goes continuously as we irradiate it with light. The longer we irradiate, the higher the chance that it will be excited. In your simulation, it assumed instantaneous. But if you look on the very narrower time scale, there will be structure. Now, if we continue to irradiate it with longer pulse, it will make the population of the excited state to go down because it will make stimulated emission back to the ground state. So for the basic introduction to this thing, in Wikipedia, it is Einstein coefficients of spontaneous and stimulated emission. So if we irradiate a molecule with light short time, it just has small probability to be excited. If you irradiate it long enough, it will have like 100% to be excited. But if you keep radiating it, the same light will induce it to return energy back to electromagnetic field. And this stimulated emission, when things go down from excited to ground, is a main foundation for lasers. So the principle of lasers is that one makes short pulses and create several molecules, like molecules in the excited state, right? And then when they all are hot, they all are excited, one just kicks it a little bit with enough spontaneous emission to produce first molecule to degrade. And then this quantum goes to another one, and it creates avalanches. It's like chain reaction. And lasers have some similarity to nuclear bombs. They have chain reaction and avalanche with instantaneous emission of everything which was excited.
So is the second pulse in that playing that role?
Yes, yes. Make sense?
Yeah. Is this stuff I should go into? It seems tough to.
Only to the way you feel comfortable and you get it, because our human strengths are limited and time is under pressure. Just just basics. If you elect to, and Joshua elect to chat to each other, let's approach him right now. Joshua, would you please tell us a little bit what you are doing and show pulses just generally? Then you can take a seat.
Yeah. Average, but then you give it a 90-degree pulse. There's only the average spin from right there, but then because this is inhomogeneous, we're going to have these placements try going faster or slower than others, drainage cells split, and as a result, and then the strength of the magnetism is weakened. And so what we do is we put like a spin pencil to it, so that's the magnetism signal is strengthened. It's kind of hard to explain. Either I mean, if you are.
So how do the pulses play a part? What exactly is your
I'm so happy. It is exactly what I'm expecting you guys to do on Friday. But to do it in writing, like reading works of each other and asking like, I do not understand, what was the goal of your project?
Yeah, I mean, to be fair, though, it's easier to review someone's right and just try to explain verbally to someone. Yeah.
I guess I'm just trying to figure out what my main observable is that I'm trying to analyze. If I just stick to 2 pulses
Okay.
and change intel. Yeah.
So I'll first answer your question to Joshua. So he elected to explore how the response of the system depends on ensemble, depends on the number of molecules in the ensemble. Like the thing that we were talking about, laser. Right? Can we build laser of 2 molecules? Maybe not. Can we make laser of 1,000 molecules? Maybe yes. And he's scanning through. There are lasers for laser light amplification, and there are NMR analog of lasers, which is called spin echo. And spin echo is what Joshua is exploring, and he's changing number of units in the ensemble for your project. The molecule that you're looking with a potential on the board is chemically stable, right? If it is in the ground state, you need to heat it to like really huge temperatures to break it on the pieces. And industrially, sometimes one needs to break molecules, right? And if it takes too high temperatures, then the reaction doesn't go. Photochemistry means you can facilitate decomposition or maybe formation of new molecules, like light as a replacement of catalyst, light as a chemical catalyst. So by applying certain pulse configuration parameters, you can facilitate breaking of a molecule, but one wants to have more degrees of freedom of control. Like you can control the rate of your reaction and stop it at intermediate place to watch intermediate, or you can revert it and tell like, no, I want you to reconstruct back. So you're not just blindly break and it, and that's it. You can continuously change some parameters to facilitate formation of a desired product at a desired time. So basically, it's an implementation of, it's not predicting future, you're constructing future. You can create a certain configuration, certain product at a certain time by tweaking knobs on your experiment, or as a big head theorist, you can give recommendations to experimental lab, tell like, make this leg of interferometers so long, wait so many femtoseconds, and you'll get this product if you select the right wavelengths. So it's not only predicting future, it's controlling the future of molecules.
Okay.
Do you feel better, or it creates more questions?
It kind of creates a lot. So I'm just having trouble looking at my the end figures and interpreting what I'm seeing with the changes I've made. I don't know. There's just so many parts to the graph that I'm maybe not.
Okay, let's look on it together and try. Yeah, many thanks for presentation.
Yeah, thank you.
Yes, I'll be back. I think Joe wants quick.
Okay. Yeah.
Question.
I noticed that after I got past the 9th state, the energy stopped appearing on the graphs. I'm wondering if that's because like the values are too high or something.
Okay, can you show what is going on? Oh, what numbers?
Yeah, the numbers aren't showing up.
Oh, okay. What not the figures, but numbers.
And this is all. And this is the one that n stays equal 12.
Uh-huh. Does it look similar to any of your?
Yeah, the previous one.
Okay. Yeah, that's good.
Okay.
So we need this text. So 2 times 10 to the minus 3, right?
Yes.
Y-axis. So let's just debug this line. Control-C, Control-V. So it is just out of the
Oh, it's
range.
out of the, okay.
So it is displaced along Z axis, and you don't see it.
Okay, that makes sense.
Okay. I need to draw, so I will draw the board and then ask a question to you. Later, I will be quickly with you. I just fix one little thing with Joe. So if we are living in the world of Bohr quantum states, it will be like up and down, up and down, up and down, up and down. Or if you do two-dimensional things, it will be like cloud positive, 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 positive. And here maybe negative, 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 which means very high angular momentum for rotations, right? And my CSI, when she presents her results, will show one-dimensional thing, but your version of code, same as version of code by Sibel, has also radial motion. So there is a probability for electron coming in and out, right? And I really wonder if you got states where instead of angular motion, there will be radial motion. So it will be something like plus and then minus. And then maybe plus again, which will mean that like plus, minus, and plus, which will mean that electron is coming closer and backwards, but not rotating. So I didn't knew how to explain it by words, but after drawing, you, huh? Not really. It's not harmonic oscillator. It's just radial motion of electrons. Did you got any eigenstates that will show radial component of atomic motion? Let's look together. Do you have like list of all of them, maybe in one place? Images.
Yeah, I do.
Can you bring it up?
Which one?
This one.
This one?
It's literally exactly. So there are no nodes and lobes on this circumference, and there is a positive, negative as we go radially.
Yeah.
So you do have, your answer is yes. So which state in the periodic table would it correspond to? Can I do something on your screen? I need the browser that you and a new window. P table. Electrons. So for ground state of hydrogen, it's 1s, right?
Yeah.
Then if you do P, it's there's dumbbells. 1 px, py, pz.
Yeah.
What is so 2s, 3s, 4s? So how does it correspond to the state that you were just showing?
It's kind of
High energy S state.
say that again.
High energy S state with zero angular momentum.
Oh, okay. Yeah, so it's
Do you see
Yeah, I see it.
connections?
yes, because it's
So there's nothing changing as we walk around the equatorial.
so the higher you go.
But if you go deeper and in and out, it changes plus and minus, right? So it's a really great finding, and it makes your work outstanding compared to work of my SSI. Her work just by methodology doesn't have opportunity to show this highly energized S states, and this makes your work standing out from Bohr model.
Okay.
Okay. Can we return to the list of? Okay, let me open them.
I need to retake a few of the pictures so I can show the values, but
Okay. This one looks like S2.
yeah.
This one looks like simplest d orbital.
Yeah.
Those are px, py. This another d orbital. Even if the energies are offset, you may group them and make connection to orbitals in periodic table. Maybe borrow stuff from there. This analysis, even if you jam it in one figure and in like 30 seconds in presentation, I think everyone will appreciate.
Okay.
And this one looks like P3P states when it has both circumferential and you see a little structure there when you get in and out. And there are X and Y rotations at different angles. So this one is S3S. And here it's like an analog of 4D.
Yeah.
When we go 3D has only circumferential, right? And if you go to 4D, you see the little structure, it goes both on the circle and in and out. So it's, and this one looks like lowest F orbital, like 4 analog of 4F. Let's find.
Yeah. I think that one.
Okay. So if you just find a way to show them and explain this connection, it will be, you don't, it's more effort of placing them together and writing, explaining it by text.
Okay.
So you already have enough material, so probably you need to focus on arranging your figures in the way that you can present in a short paper and finding words to explain it by text.
Right.
So I already, by talking to you and reading your homeworks, I know that you have tendency to be brief. Here it's not the case. If you can expand your thoughts in longer sentences, it's good.
Okay.
Okay.
Thank you.
Yeah. Thank you. Okay. Now I'll go to you.
So I thought we could look at each of these. So the main ones I was thinking of analyzing were I took a screenshot before and after the pulse. Does that seem sound?
Yes. If you would do it for like publication, you may do some like couple, 1 or 2 in between, but right now
Okay.
there is no time to
Yeah.
do things. So it's good.
And then I guess a question I have is, so at each different time that the pulse is emitted, why is so for lower values, this is lowering more, isn't it the overall probability distribution after some amount of time? Like this top distribution, why is it lower in like in this one? It goes here. And this one after the pulse, it drops all the way down there. I don't know why it's
Okay. I do have an idea how to explain, but
okay.
please try to dissect your question on smaller pieces. So you will divide and conquer answering them. So question number 1. Go ahead.
So why is this probability distribution changing at all after the pulse? I thought it would just stay at a constant energy level. I guess I don't know what's going on.
Okay. So why probability distribution changes over time after the second pulse?
The energy level, I guess, to be more specific.
So this version of code uses a trick to help human perception and visualization. One can offset energy of wave packet in respect to ground state by two ways. First, offset it by total energy, which should be constant after all pulses are done. And second way to offset partial wave packets belonging to each potential energy surface by the energy, by the potential energy only, like excluding kinetic energy. So if you follow kinetic plus potential, then I'll do it here just for one. So kinetic plus potential is constant, right? But at each point of trajectory, we can decompose total energy as potential plus kinetic. And if we offset wave packet only by potential energy, then it will be at different heights at each step of trajectory. So I don't know how scientific or anti-scientific it is, but for picture with more than two potentials, it is much easier to follow by human eye if it literally follows this line of potential energy surface.
Should that be the main thing I'm analyzing?
Huh? Okay, is it question 2 or
Yep.
so? Okay.
What should be the main thing I'm analyzing before and after the second pulse?
The white stripe on a blue background.
Okay.
How the distribution of the bond lengths changes over time.
Okay.
So what to look at, whether it bond breaks or contracts, whether it returns back. So here it is an artifact because of the final size, it's just reflection. And also
I noticed the
slope changes, and also it splits on two pieces. This your manipulation in good sense of pulses may affect how it splits on pieces, and this splitting on pieces is, I'm not telling it is of practical importance right now, but potentially an ability to manipulate this splitting on pieces relates to so-called Schrödinger-Cat quantum states. It's a terminology, it's not a joke. Schrödinger-Cat states, and it has potential applications to quantum computers and quantum information storage when one can create superpositional states. So if you manipulate with pulse duration and you change offset of this sub-peaks, it is something valuable right now, not for industrial point of view, but more for basic science point of view.
Okay. So why is the slope
Changing?
lowering?
If you bring your system into a situation of spontaneous emission, so you promote it down to the ground state, the gradient has different, and force acceleration has different direction. So on either one of the three excited states in this region, it accelerates away to expand the bond. In this region, no matter what is the momentum or velocity, it will experience negative acceleration, deceleration, either stopping expansion or maybe even pushing it backwards.
Okay. Is that why it's further behind this?
There is one more. There is one more effect. I don't have answer to your question right now, but there is an effect that when wave packet passes intersection of blue and green surfaces, it naturally splits on two, and one wave packet travels along green line, another along blue line, and optical transition may happen only between green and ground. Whatever transferred to blue will stay on blue forever.
That makes sense. That helps.
Okay.
Let me check. how would I explain the mere, the realistic research potential that this simulates? Should I add that in the paper? Like you were talking about with the mirrors?
So I've got
Just to-
I've got two words from your question: mirror and realistic, and I do not see connection. So
Okay.
maybe chop your question on two.
Um, how would I describe how this is useful for research in a lab?
Okay, so for this small test molecule, which doesn't have big industrial applications, it is more like getting basic science. And it is also not very expensive to try, but generally, computational and theoretical effort is not stopped from working with toxic or explosive materials in some extreme ranges where humans are under danger, where molecules show very short-living intermediates, where something happens on a quick transient effect that is hard to find, but maybe important to understand the mechanism. So you can monitor by following the theoretical predictions, basic processes in the molecule, and by exploring it, you can help to interpret experiments, and you can also offer suggestions how one may modify experiment, like which parameters of experiment to change and what can be obtained. Sometimes this theory-guided experiment works more efficient than experimentalists themselves design their setup. So it's like dual engine machine if there is a cooperation between theory and experiment.
That makes sense.
Okay.
Do you think I need to generate any other figures, or this should be all right? Mainly, I'm probably going to focus on this and before and after.
I think it is enough. It is the as you realize, and you already went through, the main challenge is thinking and interpretation,
Yeah.
which you're currently doing, and it's not like accumulating more and more data. It's more like interpreting and explaining.
Okay, I think this helped me understand it better. Okay,
Okay.
I should. Thanks.
Yeah, thank you. So perfect. It's like treat to my eyes and ears.
So I swung both ways.
Hmm?
So I went both ways,
Mhm.
reduced and then increased.
Okay, so this is perfect results. If they are accompanied by either experiment or ab initio theories, it will be even enough for a paper. So just, I'm absolutely happy. Just stop collecting data and start thinking how to explain it. Try to writing down. So do you have quick ideas, or just tell me what you see? And maybe, yeah, do whatever you like, but I think just looking onto your PowerPoint is enough. No, go back to PowerPoint. Explain how the change of this parameter affects the emission spectrum. Just by words.
Reduce the, we keep reducing the position of red.
Equilibrium.
Yeah.
Okay.
what's it called now? First of all, the gosh, hold on a second. I'm just trying to say like the top is smooth all the way here, but then it starts to the edges become rough. I don't know how to explain it. But then also like the line is broadening.
Yes, excellent, excellent. Yes, absolutely correct. Line is broadening, and you start seeing these individual peaks.
Yeah, like yes, that's what I was trying to say with the
From content substructure or whatever, individual peaks for vibronic transitions. Okay, and for the second part,
same thing. So the farther you go away from the, it looks like this is like the midpoint. So the farther you go out, both from either left or right, spectrum starts to broaden out, and then the individual peaks start to show.
okay, okay. So just intuitively, I think this one is the best result. Or maybe even if you would do, yeah, either this one or this one is the best. So let me explain my comments. It's not, I'm not doing your work completely, but just suggesting something. And I'll probably do things on the board. So Joe, you're done? Yeah. Yeah, I look forward to see your writing. I'm really curious. Adam, are you still here?
Yes.
Okay, I'm going to and Nate, you may stay maybe for 5 minutes longer listening how we talk to Lola. It may have a little connection to what you're doing, to you and to Adam. Okay. Oh, thank you so much. Okay. Ground, excited. So Adam was looking for charge transfer when ground and excited, or donor and acceptor, are very close in energy. Lola and Nate are looking for a situation when ground and excited are offset by energy comparable to optical light pulse, like a couple of electron volts, 1, 2, 3, like some optical. So in case Nate was interested in stimulated emission. Lola is interested in spontaneous emission, when it settles maybe in the center and then starts emitting naturally. So if the centers of these potential energy surfaces right above each other, the most efficient transition comes from the vibronic ground state in electronically excited to vibrationally ground state in electronically ground. So only one transition. And it will give only one peak on the emission line. If we come to situation when potential energy surfaces are offset, then there will be emission from vibrationally ground electronically excited, this one that I'm marking with blue, to several quantum states in the lowest potential, to the like third, second, and first. And they will happen at different transition energies. So for optical emission, like we will have line at frequency number 3, line at frequency number 2. I'm using the same lines here, and line at frequency number 1. Therefore, emission that one can observe with spectrometer looking on the same as we did in the demonstration, but instead of hydrogen lamp, it will be just a molecule. One would see not one line, but splitting because of vibrational substructure. And Lola's question was, what is, if you already know the spectrum, what is the right offset of the parabolas along x-axis that will provide realistic spectrum? So if the offset would be too much, if you have the configuration same as Adam goes in the limiting case of very big offset, this quantum state will not overlap with anything below. It will overlap only with high lying state, and too big offset of equilibrium coordinates will be not realistic for emission. Also, if the excited state potential will be on the other side in this configuration, it will be not emitting. So the minimum should stay within these frames to be efficient emitter. It's I'm not telling you need to redo anything. It's just analyzing the data that you already have. Does it make sense? Okay. Nate, do you see any connections to your work?
Maybe.
So you haven't performed eigenstate analysis. You do not need to. You already have enough. But if you are curious, there was a code like state eigen 4 or state eigen 5 that was distributed in class, and if anyone wants to help Nate, you can forward him this code. State eigen, oh, do you have it? Yes. Would you please forward it to Nate? It's not mandatory, but if you're curious, you can try and see if your system has also eigenstates exposed. Adam, do you see any connection between this explanation and for Lola and your project?
Yeah, I do.
Okay, good. Yeah, thank you. Lola, do you have more questions, or you're done for today? Excellent, excellent, thank you. I'm going to talk to Adam unless there are, and if you need to leave, that's fine. Okay. Adam, would you like to share screen just to quickly check if you have any questions?
Yeah, sure. Right. Yeah, so here's the plot, the brand new plot. The 20 points additionally between 0 and 0.01. So I should just talk about why this this variation occurs.
Right.
Okay.
Exactly.
Okay.
By the way, did you try to connect your points by line?
No. How may I do that?
Let's do it and just check what is going on.
Sure. Is there a command for it?
If you bring up the yes, arrow up to bring up this line. And,
Oh, in this?
No, in the command window.
Oh.
Now do O minus in the very last, at the very end. O minus.
Ah.
Enter.
Oh. Yeah.
Okay. So, what do you see? It looks like they're not random.
Yeah. It looks like they're not random, you said?
So how would you just verbally express what you see? Is it like a tooth of a shark, or
Yeah,
mushrooms after the rain?
it looks more like broken glass.
Okay. How many? It looks like defined peaks. How many peaks do you see?
I see 6. There are 2 small ones in here, but
Okay.
making 8. Yeah.
So let's make a little mathematical or computational experiment. Let's just focus by human eye first on the tip, on the top of each of the peaks.
Yeah.
Okay, so now let's define also just by human eyes and human brains energy offset between these little peaks.
Define the energy offset.
Yeah, offset.
Oh.
How far the one peak is from another one.
Oh, it looks like oh yeah, it looks about 0.25, maybe like 0.3, or I'm sorry, not 0.25, 0.0025.
So here is the question: is offset between each neighboring peaks different or approximately the same?
It looks approximately the same.
Yes, so it's your discovery. You can just type it in your discussion section. Okay,
Yeah.
That's great. That's great. Now, did you try to plot eigenstates?
Yes. I mean, you mean in eigen, like states,
Yes,
states eigen?
States eigen for whatever. Do you
Yeah.
have results of this code stored in your PowerPoint?
Not stored, but I could run it.
Do not run. Open new figure, otherwise it will damage the figure that you show. Type figure and then run this code. Type in the window. Type figure. No, in the.
Yeah.
Sorry, I'm too excited. Type figure. Yes. Just figure. No. Just figure. That's it. Enter. Yes. Now you can just go into your like states eigen for. Type states eigen for. Enter. No dot m. Just this way. Okay. And let's click on the next, the one that lower. Yeah, sure. Bring this up. Okay. So you have told that offset between individual peaks in your main result is, you gave some number.
Yeah, 0.0025.
Let me record it. 0.0025. Would you please multiply this 0.0025 by 27?
Yeah, sure. But yeah, get my calculator.
In Matlab command window, it is a good. Yeah, just type here this. Yeah, sorry.
Yeah.
Okay. And now let's look on here. So 0.06. Does it correspond to anything in this figure?
Yeah, it looks like the maximum of this. Maybe.
So I wonder if the offset. Let me click something. So here is the ground state, right? I'm pointing it. And here is the first state. What is the energy difference between them?
Roughly 0.65, about
0.65 or 0.065?
Yeah, 0.065, sorry.
So how does this relate to the number that you computed? Is it far or similar?
It's similar, yeah.
So would you agree that likely the individual peaks in this figure correspond to? I just want to stay silent, muted for a little bit, and ask your opinion. So would you come up with any interpretation and connection between offset between these peaks
Mhm.
on one hand and offset between vibrational states on the other hand?
Oh, it's tricky. You mind if I get rid of these? Yeah, this would be 0.66. 129. Yeah, I don't know about that. It almost looks like the maximum of this parabola or
yes.
wave function. Maybe it's the difference between the maxima. Is what I'm trying to say.
Okay, it's your discovery.
Okay.
You should claim authorship and immediately publish. So did you try to make this eigenstates figure for each time you did run the dynamics, or you missed this point?
Oh no, should I have?
If you have time, yes. If you like, not right now, not in my presence, because it will take another hour. But let's imagine that you redo it after each run.
Mm-hmm.
So where would you expect to be this bluish excited bluish parabola? If you right now it looks like you are looking for the rightmost portion in this figure, right?
Yeah.
Okay. So where would be the this bluish acceptor parabola if you set up energy of set equal to 0?
It would be equal. It would be level.
So it will be like here at the bottom, correct?
Yeah.
So what can we tell about? Would you please assist me and remove these marks? I know how to make things dirty, but I didn't learn how to make it clean. I apologize and thank you for cleaning.
No worries.
Okay, so look at this bluish parabola and see there is a little red structures.
Yeah, I see them.
So if we put the bluish parabola down, this red eigenstates of the blue parabola will be also level with the eigenstate of the red parabola, right?
Yeah.
Their energies will be equal.
Mm-hmm.
Equal energy means resonance.
Yes. Yeah.
Okay, and any transfer processes, just by laws of physics, we later can discuss it, happen much quicker if there is a resonance between initial and final state. Would you buy it?
Oh, yes.
So
that makes a lot of sense.
As long as you move, so your experiment, if you probably should do this figure for each point you computed. And then your experiment means that you pull blue parabola from top to the bottom.
Yes.
And at the peaked, at the specific value of the offsets, the eigenstates of the blue parabola come into literal resonance with eigenstates of the red parabola. Right?
Oh, that makes so much more sense. Yeah.
Then it happens much quicker. If they are in a good Marcus regime, but they are halfway offset, then it slows down the transfer. And then you have dips in your rate versus energy.
Yeah.
So you are observing individual vibronic resonances, and it explains your broken glass structure.
That makes so much more sense. Oh, God. Okay, thank you so much.
So please, if time allows, please try to. I think writing down by text is more important, but if time allows, also try to do a couple of runs for this eigenstate parabolas, because it will be visually much easier to understand what you have done by your readership.
Yeah, that seems absolutely critical to me.
Okay. Any other questions from your side?
No, I have none.
Okay, then you're welcome to disconnect or stay here, whatever you feel comfortable. I will talk to Sibel and Wyatt, and we are about to finish the session soon.
Okay. All right. Thank you very much.
Thank you. I'm very happy for your progress. It's really interesting work.
Two questions.
Yes, please.
The first one, what view would be best?
So you can offset is your objective measurement. You cannot, you shouldn't trick it, right?
Yep.
But the
Well, this is-
absolute value of this probability, if you multiply it by like factor 0.1, no one will criticize you.
And then it'd be spread out more.
It will be like if they are offset as they already are, but you multiply the actual probe by like 0.1, they will stop crossing each other, and the image will be less busy.
Okay, where would I or would I multiply it in the plot?
Yes. Psi-ig. Yeah, in front of abs, do 0.1 multiply. Yeah, sure.
Oh, okay.
No, yeah. Okay.
Or wait.
Yeah, it's fine. You can. Okay. And then they will be offset and do not.
And then do you increase that every time or just?
No, keep
No,
constant.
the
Keep
same.
constant.
Okay. And then second question, so this by hand rate, I did it for both, and it's still not linear, but it looks a lot better than that does.
Okay.
So
And the data for lowest temperatures are mostly appreciated. The rest is also interesting, but activation energy obtained from this smallest, the activation energy computed in different ranges of temperature will change, right? But
so use like 2 or 3 of the most appropriate temperature values,
yes,
and then you use that slope
to find activation energy. If you know what you're doing, I'm happy. If you don't, I will be happy to give details.
Okay.
But slope is energy, right?
Right. And then you'd set the intercept to be 0?
It doesn't matter. Only slope is important.
-11.
Okay.
And this one. -38. So
So
the
and the activation energy is negative of the slope. So without king, it is 38 units. I'm not fresh to say which units, and with king, it is 11 units. So it's the activation energy is 3 times
Greater with no king.
more favorable, right? With king, it is it's 3 times more favorable to overcome from one side to another.
Oh, yes.
Without
Yeah. The energy, yeah, I get what you're saying.
so no king goes easy. With king, it stops. It doesn't want to go.
Mhm. Okay.
And just with a fresh head, it would be great to convert into like electron volts or some other units. But right now, I will definitely make errors because being not fresh.
So then in my report, it'd be best including charts such as those, including activation energy.
Formulate all your activities as a set of evidences
Right.
in support of this quite understandable and natural idea that king prevents electrons penetrating from one side of chain to another one. And you have some quantitative measures of this effect.
Okay.
So if you like provide only those results that support this idea, because otherwise it could be too long.
Mhm.
And since we are trying to present it short and all together, being short is not bad.
Okay.
Well, I'm not telling like write one paragraph for the whole work, but
Right.
do not do more than 4 pages.
Okay.
Well, if you saw works from previous years,
Yep.
there were like 11 pages works, and some people get really excited and inspired.
So then, okay, one more.
Yes,
time. This
yes.
is saying, so activation energy to overcome the kink is less than the amount with no kink.
Right. 11 and 38. 38 is bigger than 11. So activation energy is minus ln k2 1 over time 2 minus ln k1 divided by 1 over t1. Something like this.
This is saying that no kink is 30. And kink is 11.
Your results.
So this is no kink 38. And this is kink 11. That's why.
Let's rub the theory around the results. Okay. So when the rate is higher,
Right.
this absolute values of the rate, what are they higher?
The rate is higher at higher temperatures.
No. If you have keep the same temperature, just 1 point, maybe second point, whatever.
Okay.
Yeah. And compare with king and without king.
The rate with no kink is a higher rate.
Okay. It is good. It is natural.
Okay.
Now let's check how the rate is increasing with king and without king. Where its increase is bigger. Like if you increase temperature, the rate is also increasing. Where it
Right.
increases more vividly.
At higher temperatures.
If you give the same increment of temperature, like going from 200 to 300,
Yeah.
where the rate increases better, with king or without king? Like what is?
No kink. I mean, because the slope is greater, so then that would mean that with no kink, the rate increases at a faster rate as temperature increases.
So from these results look natural, right?
Yes.
You just slightly perturb it, and reaction goes quicker.
Right.
So we just need to manipulate this definition, putting plus or not putting plus in here. But let me share what others wrote in the same circumstances,
Okay.
and we'll try to come up with interpretation. But the raw data look reasonable.
Yes.
It's just a little blinking out
Yeah.
in the interpretation, but I have no doubts. Everything looks reasonable. It's just too long day.
Yeah, I think so.
Maybe you should like stop doing anything and relax.
Start tomorrow.
Right.
Okay. Yeah, I'll do that. And then look at the other data.
Mm-hmm. Yes. If I forget, please send me a reminder for. I really want to share with the whole class works of previous years. It's already a bit late, but tonight is much better than next night when things will be due.
Okay. That's it for me.
Okay. Yeah. Thank you for enthusiastic work.
The rate
Uh-huh.
all comes out to be the same. Using this equation where I have to identify my average with the
Okay. So first, we shouldn't worry because your project is like 10 times heavier than any other in computation. So and it will be.
I should worry about it in the rate. Because, yeah,
It will be not a problem if you do if you progress a little bit less than others because the system is more complicated. Second, I hope you did record this images of this thing.
yes, I have recorded the images of mine. Yeah, so this one was for the initial position.
Okay.
Then
Did you record the images in form of as a screenshots in PowerPoint or Word?
yes.
Can I see it?
So this is the initial as I showed for this part.
Uh-huh.
Then this was after some time T, which was in here.
Uh-huh.
And then I did one for the when it was here.
Mhm.
But I didn't take a screenshot of that.
Mhm.
I'll take a screenshot of that when I get home.
Okay.
Thank you.
Yeah. Thank you.
Yeah. And I plotted which you can see.
So let's compare.
Both of these. Or
Mm,
do you want to
Can I?
Yeah.
So I'm just trying to look at several things at the same time.
But when I took at this point, basically it was just a flat line.
So
That's fine.
I'll try to explain what I see, and please correct me. So it looks like a snapshot.
Yeah.
Is it same run or two different runs?
It's two different runs.
So after different,
It's everything, the two different, like the positions are different.
positions are different,
Yeah.
but momenta are the same.
Momentum are the same.
So for comparison,
I should take different momentum. But
For
even
the
even when I changed the momentum, because I played around with like the initial position momentum,
Mhm.
it didn't change. It didn't change. And I also did the same for this one. It didn't change. The momentum didn't change. The probability like this didn't change. Since I because that's what I was working on first, and after I decided to work on the rates.
So this is like probability of a product,
of the
right?
product, yeah.
Cancel. I'm just trying to increase this a little. So what, and the x-axis is time.
Yes.
What if you do the same thing as Wyatt has done? So keep it. I'm going to speak a little bit more. I'm just looking for something a little thinner than this one.
Should I give you a pen?
Yes.
I do not have paper though. Oh,
No, I don't need paper. Just a pencil. Yeah, thank you. It's just a little easier to show. So if we forget all coding and do just very raw human estimate about the slope of this curve. So we take increment of the y, which will be like let's see, between like
should I pull up the- I should have it on. Okay.
okay, so maybe 6 minus 2, 4. It increments by 4 during 400. So 4 10 to the minus 4 divided by 400. And we should, it starts not at 0, but a little where. So the slope will be like 10 to the minus 6.
Or
4 to the 10 minus 4 divided by,
would be, yeah, 10 to the minus 6.
okay, now what is the second run?
I do not, I had it, but I deleted it.
But let's bring it, if it's not available, let's bring it here in the board. Now let's look only on this part. So from 1.5 to 3, so it's 1.5 divided by like 200 or 250. So 1.5 10 minus 4 divided by 250, yes.
6 times 10 to the negative 4.
Is it bigger or
To the,
small?
to the negative
7.
It's,
Is it bigger or smaller than previous?
it will be, this will be smaller.
Okay, so those are two rates.
Yeah.
So they're different.
Yes.
Okay, so you've got it.
Okay, so that's what I should do.
Yes.
Even though it's different position.
Yes.
Okay, so I should just take, so I should take many positions and then just.
Do not overwork, just whatever you can do in
Yeah,
a
no,
limited time.
I can take many, like different, like various positions between here, the curve, and then calculate the rate like that. Yeah, when I was doing it in the Matlab using the code version. It was
Okay.
just giving me
Yep,
this.
it's a good way out.
Okay, that's what I was doing. Sounds good.
And did you watch what Wyatt was doing?
Yes, yes, he converted even.
Like log of the rate
rates, yeah.
divided by 1 over
Yeah,
temperature.
Yeah, I have all the math on the table.
Wait. I'm happy with what you're doing, but the theory is designed for response of the model to the temperature, not to position.
Yeah,
So
now I'm changing position though,
if
because when I
Well,
changed, that's why I was trying to change the momentum,
right,
but it wasn't changing at all. At the probability versus time was exactly the same. I increased it even 18 times the momentum.
18, can you do it 100 times more, or direct it slightly different?
Well, I can do it while we're talking, so that you should be doing and seeing.
It may not as a productive run, but just as a little test exploration,
So,
wild data.
okay, and let's make it 25.
Okay. No, wait. No, if you change number of points,
Oh, yeah, what's changing?
your everything, your definitions are changing. No.
So
You shouldn't.
just leave this and just change it to, let's go to 100.
Yes.
Let's see.
Oh, wait.
Haven't changed
P not. Wait. Isabel, I wouldn't say it's a bad news, but it's a little hint. If you change P naught, it doesn't affect your results at all. I promise.
P naught.
Because you need to change P naught X and or P naught Y. You were changing P naught only?
Yeah, but then I tried changing P naught X to the.
Let's do it. It will not change anything. Let's do 200 here and 200 there. It may give something completely like safe and run. It may like bring some numerical errors and wrong calculations, but just as a exploration that system responses to our attempt to increase momentum. But do not worry. Do not worry. You are like going on the frontier of anyone in this class through the last 12 years. And you're doing very complicated things. Even small steps are much appreciated. So even do not think about panicking, even if something doesn't work. You already accumulated really cool things. So it looks like we are sending it, I cannot see, by diagonal, either here or there or there.
But then if the moment, if you're changing the px and the y, if the probability doesn't change, then how can I make that table, but this time align the position instead of just
Wait. I have yet some reminder of the brain, and let me try using it. So please put your. I think you're trying to connect several questions into one. Can you please chop it and ask little by little?
So how can I use like how we did with the momentum, right, with the table, but now I should do it with position instead of momentum. So I will
Wait. I have enough input. Doing it with momentum only is the most traditional, canonical, best working way. So if this run will be successful, you probably should keep with momentum. If we still discover that the system doesn't react to change in the momentum, we may scan different positions, but at each position we should run twice, like with zero momentum and with big momentum. And then we still need to compare two values, two results just made at different temperatures or different values of momentum, just see where at which point system responds to change of momentum to a bigger extent. Because comparing position to position is interesting, but it is too novel. There is no fundamental theories behind it. Then you need to design everything. And if you follow the protocol of Arrhenius law, it is much easier, and everyone will understand what is being done.
Makes sense. So almost done. 500.
Mhm.
Oops.
Okay.
So this works. Works fine.
Okay, but and which one is the biggest
The biggest is AQ11
and second biggest?
will be AQ.
22?
22.
Let's check. No.
One, two, maybe.
Two, one. Can we understand which quadrant corresponds to 2, 1? So it's like this one. So let's check this x of, how do we call it, border?
Yeah, but
5 and 5. Okay, they're close. 5.2. We should. I was designing this number for when the number of points was 55. Let's take a smaller value. Let's take it maybe like 4 and 4, which will be like 18. And what it is defined? Can you find?
the number of points.
Yeah, what is border x is defined?
Mm,
Okay, so let's change it at least to, yeah.
border y 18. Keep the number style, so maybe you can go for. So we can- so put it 2.5.
Why? If you want the code to work quicker, then you just change n tau. You keep it 1, n tau like 200. Why are you changing dx?
Oh, no, I changed the x when I changed the n number of points, right?
Right. I would also try to change just sign in front of X and Y. So this lines should go in. Maybe the best would be to change both, like make plus here and minus there. Then it will be going towards the product as quick as now. It goes at a like 90 degree, so it doesn't approach the final state. We'll figure out what is going on, but such linear change is very easy to process and find slopes.
Yeah, exactly.
And probably it will be very responsive to
Yeah.
to what we do. So if now we can on the same, we can also plot the time. So it leaves one area and arrives to another one. It makes sense. Okay, and let's do one more. Probably it will be last run for today. Let's where is px py at the very beginning? Oh, yes, I see it. P not py. So what if we minus? So there are totally 4 combinations, and one of them should make it like a rocket to make transfer most efficient. You better run and operate the figures. I'm surprised. It's still like I want these lines to be in different direction. Well, we still have 2 other combinations when both are plus and both are minus. Yep. Please send me this version of the code tonight. I do not promise, but I will try if I do not follow. But you cannot run 2 copies simultaneously, right? It will the computer.
The other one, so it's not running.
Oh, okay.
Yeah, because that's.
Oh, okay. Okay. Yes. Yeah. I follow your train of thought. Okay.
in a way, so that's why I
Mhm.
just stopped.
Yes.
It's going the direction we want it to go. Right?
Yes. It's a productive.
So do you want me to try the minus, both
No,
minus?
no. We should just complete this one.
So, oh, you want me to complete the run?
Yes.
Sorry.
By some reason it, oh, probably did different process. It just slowed down.
Then I should just play around with the psi naught then, the psi naught x and y,
Mhm.
and calculate the initial rate for the
Mhm.
carriers. So should I keep one of them constant or should I play around with both of them?
Probably both of them to the same extent.
Still,
Mhm.
yeah, okay, the straight line, which is
And,
easy
yep.
to measure the slope.
Okay. Okay. And just as a just checking what will happen if they both are
Negative.
right. Okay. I have here to make it bigger so that it is it okay to save on the same name?
Yeah, I'll just change the symbol.
Okay.
Okay. Big here. That's fine. Oops. Yep, first time doesn't work. Second time works.
You see, it breaks on little pieces. It means grid points are not enough. So probably 200 is better.
Okay. Yeah, so 300 is now.
But let's keep. Do you think the shape of the probability distribution changes from circle to oval?
Yes, over time.
Yeah,
Yeah.
and it expands in the right direction.
Yes, it does.
Okay, which is not bad.
Yeah.
So I think although this 300 is not trustable, we see it from the image, but it probably big error, but overall direction of reaction goes. Yep.
Yeah, so yeah, when I ran it longer, it
Mhm.
changed.
Okay, and now let's
Figure.
okay, this one falls, or so reactant decreases, product grows. I think this one is most correct.
So I should take the negative sign.
Yeah, keep the negative sign and just play with absolute values of both. So like maybe like 300, 250, 200, 150, and see how slope depends. And it should be enough. Whew. Oh, thank you. Yeah, see reaction goes backward direction.
I was trying to compare.
Yeah.
I just needed more evidence.
No, I think we did a great breakthrough. It's now it's all logically consistent. Oh, thank you. My pleasure.